if we put exaggerated pressure, if we put exaggerated Assalamualaikum and a very good day. So today for the subject Integrated Design Project BMCG 3013, our group 6 will present to you about our project, the BDA Thermometer. So the objective of this video is to showcase about what our prototype does and to show how we fabricate and make the prototype. Next, let's take a look at the customer requirement and engineering characteristic, or CR and EC. CR and EC can be observed in the House of Quality or HOQ as shown. The customer requirement is about the features of our product, BDA Thermometer, and the engineering characteristic or EC. Over here is about the engineering specs of our product. Now you might be wondering, how does the thermometer looks like? Imagine a handheld digital thermometer with two displays, one at the front and one at the back. The grip is textured for a much better grip, and it comes in various color that suits you. The thermometer also features an optional strap with a clip for much better mobility and safety. You can use it to hang it on your clothes or hang it on the wall. Next, let's take a look at the component and material used to make this wonderful product. We start with the acrylic low nitrile butadiene styrene plastic or ABS plastic for the outer body. Next, we got two organic light emitting diode OLED panel for display at the front and back. Breadboard to connect the components, ESP8266 DS18B20 sensor web server, Arduino IDE for the heart of the project, trigger clicker switch, temperature sensor, and two rechargeable batteries for power source. The ABS plastic then will be used in 3D printing to construct the main body according to the model created in SolidWorks. This is how the model looks like. The Arduino, on the other hand, gets connected to the computer and the important code is set and transferred. The OLED display, Arduino, trigger clicker, temperature sensor, and rechargeable battery will be soldered and connected on the breadboard by using some wires, soldering iron, and solder. As everything fits and secured, it will be tested. For the analysis purpose, we also construct the model of our product in SolidWorks and make the engineering analysis in ANSYS software. Let's take a look. For the load, we put 3 loads on the model. We put the load on the trigger, on the back of the model, and on the grip. Next, we also put constraint on 2 places as shown in the picture. The result we get is as the following. The first one is for the total deformation. The maximum total deformation on the model is at the back, where the user will usually rest their thumb, which is about 0.34011 mm. Then we got the result for the structural error for the model. As in the picture from the ANSYS analysis, the total deformation is 27.479 at maximum. The result is positive for the design to be used. There is only small structural error occur at the end of the grip if we put exaggerated pressure there, which doesn't normally happen in daily use. You may ask, how does it work and how to use it? So let me introduce you to Ali. When Ali goes to a premise or shop as a good Malaysian citizen, he will scan mass gesture code and scan his temperature on a basic thermometer. However, with the ordinary thermometer, Ali can't access to his temperature data once he left the premise. Mass gesture map also doesn't have temperature saving feature that can be seen on its in-app map. Luckily, with our product, the BDA BDA thermometer, we can access our temperature data when we use the thermometer. When Ali used the BDA thermometer, he and the person who clicked the trigger can see the temperature taken with the two display installed. When the temperature data is taken, the thermometer will send the data to the cloud through the Wi-Fi network. Ali can now see his temperature and where did he went on the in-app map in the app specifically for the BDA thermometer. By this, citizen can see how much people went to a certain places with the BDA thermometer and avoid the place if the temperature data is too high. Maybe one day we can integrate the technology of our product with MySejahtera so that the app can register your temperature data as well as checking in when scanning the MySejahtera code. Next, let's talk about the impact of our product. The first one is for health impact. As thermometer is currently being used worldwide as one of the apparatus in preventing the COVID-19 contagion, we can see that our product really benefits the society with its special feature and Internet of Things IoT capabilities. The COVID spreading can be decreased and citizens can get a much better and accurate information about their and others' temperature data anonymously. If it got integrated with MySejahtera, the function can be much more, providing us the exact number of customers at a certain places. By this, crowded places can be avoided, thus decreasing the COVID-19 contagion. For the environmental impact, our product is made from repairable component. By this means, we can get it back to work if it gets broken without needing to purchase a new one, thus reducing the need of getting more material. With less material taken, less environmental pollution there is. Our product also can be easily recycled for a much greener disposal. Throughout this video, you may be wondering of how much our product costs. So now let's take a look at the cost for the individual components and fabrication costs. In this table, we can see the price of each component. It has 11 components, each with either 1 or 2 pieces with the price ranging from 80 cents to 57 ringgit. Adding up to all these prices, the total will be at 193 ringgit. From the total cost, we go to the break-even analysis. This part is to explain about the variable cost, selling price, and fixed cost as in the table shown. Variable cost is the cost for our components, which is 193 ringgit. Fixed cost is a cost for charges in using apparatus or rent of the place in fabricating the product, which is about 125 ringgit. And lastly, we are planning to put the selling cost at 250 ringgit. And lastly, we can see the break-even chart created according to the table below. Note that FC is fixed cost, VC is variable cost, TC is total cost addition from the FC and VC, and REV is for revenue. Using calculation, we get the BEP or break-even point at 2.192982. In the nutshell, this video reaches its objective of showing what our prototype does and how it was made and fabricated. From our video, we can see the possibilities of commercialization of our product mainly due to current situation, its functionality and aesthetic. The COVID-19 situation might not end in a short time, so we can see that people can still be using thermometers. At the end, it is our customer's choice to choose what's the best for them. That's all from our group 6. Thank you for watching our video. I hope you all enjoy it and see you again next time or not. Bye bye.